In the last video that we did when we were simplifying via division, one of the last problems dealt with, we ended up with a radical down in the denominator. And in many math circles, that's a no-no. Basically, what we need to do in those cases is called rationalizing the denominator, rationalize the denominator. Its meaning is we're being asked to clear radicals from the denominator. So we usually, a nice simplified radical expression has no radicals in the denominator. That's different than saying that's a fraction, right? This would be okay, right? The square root of x over 7. This would be considered a simplified radical expression because there's no radicals in the denominator. However, if I reverse that, right, this is the guy that we would have to rationalize because there is a radical down in the denominator. Okay, so that's what we mean by that. So how do we clear the radical? Well, in order to do it, we're going to actually use two things here. The first one is the good old idea of equivalent fractions. Again, remember to build an equivalent fraction, like let's say we have a nice simple fraction of 2/3. To build an equivalent fraction of it, what I need to do is whatever I do to the bottom, if I multiply the bottom by 5, I've got to multiply the top by 5. This is the idea that keeps us in perfect balance so that my new fraction, 10 over 15, this fraction right there and this fraction right there are equivalent. Their pictures are different. This is breaking things up in thirds and using 2 of them. This is breaking things up into 15 and using 10, but the ratio is the same. And for you calculator lovers, right, they're both 0.6666666 on forever. So that's the important step to create an equivalent fraction. Because we're doing the same thing to the top and the bottom, we are guaranteed that this fraction is going to be the same. Of course, we saw that earlier in our semester as well, like when we even took x plus 1 over x plus 1. Right, so we build an equivalent fraction, 2 times x plus 1 and 3 times x plus 1. Of course, we could distribute if we wanted, but this fraction here is equivalent to the original fraction we started with because we did the same thing to the top and the bottom. So very important skill, and it's one of the reasons why I've been so hard on you guys when you're not showing it. I've taken points away saying, please show me this step because we're going to use it. We need it. We needed it in chapter 6, and here we are again in chapter 10, where this concept of equivalent fraction is important. With that in mind, the other thing we're going to try to use is we're going to use the equivalent fraction idea to basically build this concept. All right, we've seen time and time again over the last couple of sections is that if my power matches my index, basically everything kind of wipes itself clean and we're just left with the a. So like if I have the 5th root of x to the 5th, that becomes x. And again, we're assuming that everything's nice and positive as well, so we don't have to worry about those crazy absolute values. So, you know, if I have the cube root of y cubed, then everything wiped itself clean. So the idea to rationalize all these denominators here, we're going to make use of an equivalent fraction. So what do I have to multiply to the top and the bottom so that I can create this situation down in the denominator where my power matches the index? So let's see how that's going to happen. So down here, right, we have a square root of 5. So I need to, in order for the multiplication to be defined, I need the same index. All right, so we have a square root, so I need another square root. Whatever I do to the bottom, I have to do to the top. The power that I need, since the index is 2, right, I basically need the square root of something squared. We already have 5 to the first power, so all I need is another 5. And of course, whatever I do to the bottom, I have to do to the top. And if we multiply now, right, so there's my equivalent fraction. 1 times the square root of 5 is the square root of 5. And then of course on the bottom, I have the square root of 5 squared, or what you guys would probably call 25. And because of this step right there, because I was wise in choosing that, I now have a power matches the index. So the numerator stays as the square root of 5, but the denominator is now 5. And so what we have here, and you can use your calculator to check this, is that this fraction right there, 1 over the square root of 5, has the same value or the same meaning as the square root of 5 over 5. What's nice about this guy is under the math rules, there's no radicals down in the denominator. This guy is not simplified because there's a radical down there. And again, I wasn't there when they made up the rules. We're just using them. So notice how that worked. I'm using an equivalent fraction to build, all right, the situation where I can use a power equal to the index so I can clear it. So so there's what we do. So the next one, we actually have a cubed root down here. So in preparation for what we're going to do, in order for the multiplication to be defined, I need another cubed root. And then whatever I do to the bottom, I have to do the exact same thing to the top to be equivalent. So what do we need? Well, again, since I have a cube, I need something where my power matches the index. I need a third power in the radicand. Right now, this 2 is only to the first power. So if I multiply it by 2 squared, and then whatever I do to the bottom, I do to the top, this is actually going to get the trick done. So multiplying 1 times that numerator gives us basically the cube root of 2 squared. Down here, a cubed root times a cubed root is another cubed root. 2 times 2 squared is 2 to the third. So pretty neat trick, right? So we're using the equivalent fraction. We're being wise in what we're choosing so that I build this situation, that my power matches the index. To finish this guy off, the numerator is what it is, right? As a matter of fact, if you want to write that as the cube root of 4, you could. And then down here, my power matches the index, so we have a 2 coming out. So there would be our simplified version, our rationalized denominator for that situation. And again, what we're saying is that this fraction is the same as that fraction, just the one on the right simplified. So hopefully you're getting the hang of it. So the equivalent fraction idea, using it wisely to build my power matches my index idea. So in the next one, the first thing I note, the radical down in the denominator, so we need to rationalize. I have a fourth power. So I need, a fourth root. So I need to be multiplying by a fourth root so that the multiplication is defined down here. To clear a fourth root, I need, right, a power of 4 inside. So right now my power inside here, this is x to the first power. So I essentially need x to the third power there. Whatever I do to the bottom, I do to the top. Multiplying, if I multiply the top, I get 4, the fourth root of x cubed. If I multiply at the bottom, a fourth root times a fourth root is another fourth root. And x times x cubed is x to the fourth. I did it. All right, so my powers match. So in the denominator we have x, and in the numerator we've got that ugly looking thing. So again, the idea is that this fraction is equivalent to that fraction, but this is the simplified version of it. All right, let me do one more, then I'm going to cut this video and do the next 4 on another one because we're already getting a little lengthy. So the next one, my radical is a fifth root. So I'm going to be multiplying by a fifth root. All right, that way the multiplication is defined. What I need is to match the power. But right now I have an x cubed. So in order to match a 5, I need an x squared. Whatever I do to the bottom, I do to the top, right, to maintain my balance. And so we have the fifth root of x squared upstairs. And then doing the multiplication down here, a fifth root times a fifth root is a fifth root. And then x cubed and x squared would give us a x to the fifth. I did it, right? So the top is what it is, the fifth root of x squared. Here my power matches the index, and we're left with x. So again, we're claiming, well, we're not claiming, we know that the fraction 1 over the fifth root of x is equivalent to the fraction, the fifth root of x squared over x. Okay, so why don't we cut it down there? We're almost at 9 minutes. I'll come back and I'll continue to rationalize the denominators in the bottom row.